We looked at the sine rule yesterday, and yes, it's great, but it doesn't cover every situation. So we also have our cosine rule. So let's work out how we come up with our cosine rule. So once again, I'm going to drop the perpendicular height in of this triangle. But this time, instead of using trig, I'm going to use Pythagoras. H squared is, of course, b squared minus x squared. But if I use the other triangle, then c squared would equal h squared plus a minus x, all squared. So therefore, c squared is b squared minus x squared plus a squared minus 2ax plus x squared, which is b squared plus a squared minus 2ax. Okay. Now I'll use the trig. X over b is the cosine of c. So I can substitute in for x, b cos c. And there's our cosine rule. C squared, well, we probably normally see it as a squared plus b squared, but it doesn't really matter. A squared plus b squared minus 2ab cosine c. But once again, that was using the perpendicular height coming from A. I could have come from B. I could have come from C. So, yes, A squared is B squared plus C squared, but B squared is A squared plus C squared. C squared is A squared plus B squared. It's basically Pythagoras' theorem, but just been tweaked a little bit. See, if I was in a right-angled triangle, that angle would be 90 degrees. And the cosine of 90 is 0. So the minus 2bc bit disappears and you get Pythagoras' theorem. A squared is b squared plus c squared. So it's an extension of Pythagoras, if you like. So let's have a look at an example. So for this one, it's little t I want to find. So I'll have t squared is f squared plus m squared minus 2fm cos t. Subbing in, bit of calculator work, but what we've got to be careful with here is, remember, this is t squared we're finding. So in order to find t, we will have to go square root of that particular answer, and in this case, to the nearest whole number, 8 units. Well, what about if we want to find an angle? Well, the angle is f, so I'll start with f. F squared equals a squared plus s squared minus 2as cos f. I need to rearrange it to make cos f the subject. Now, some people like to memorize that formula by itself, and they know, well, if I'm going to find an angle, then it'll be the cosine of the angle. Then on the top of the fraction, you have, in this case, a squared plus s squared, two sides and the included angle. So you've got two sides of the included angle, so it starts off with those two sides, but then minus the opposite side, and then on the bottom we have 2 times, and again, those two sides. Personally, I tend to just remember the one formula and rearrange it each time. It's just a matter of personal choice, how you do it. Subbing in, and we get, and remember this is finding cosine of f, so once you've worked out that fraction, however your calculator does it, inverse or second function or whatever you have to press on your calculator. The nice thing about cosine is, unlike sine, it does tell you if it's an obtuse angle. So it will tell you straight away. And this one is 140 degrees, 33. Now, let's have a look at this one. Well, now I've got a problem, because the cosine rule, of course, we use the angle and the two sides either side, but that's not what I've got here. And the sine rule, if I want to find a side, I'd need 2 angles. I've got a dilemma. But actually I don't. I can still use the cosine rule. If I've got an angle and 2 sides, I can use the cosine rule. The cosine rule, I'll put it in terms of the angle. The angle is A that I know. So A squared is B squared plus C squared minus 2bc cos A. If I substitute in, no problems, because B is still the only pronumeral. I'm now solving this equation for B. So I've got 9 equals B squared plus 49 minus 14b cos 25. Well, it's a quadratic equation. Unfortunately, it's a bit hard to factorise, unless you're very clever. What multiplies together to give 40, okay, yep, I can think of all the different numbers multiplied together to give 40, adds together to give minus 14 cos 25. Oh, that's a bit of a problem. So we'll go to our formula. Thank goodness for our quadratic formula. Negative b, so 14 cos 25 plus or minus square root of b squared becomes 196 cos squared 25 minus 4ac becomes 160 all over 2a, which is 2. I end up with 2 possibilities. Now, unless I've got more information, I can't narrow it down. It's either going to be 5.85 or 6.85. And looking at this triangle, I haven't got enough information to tell which one it's going to be. Right? I know 3 is opposite 25, so there's a pretty strong chance 3 is the smallest side. But that's fine. 5.85, 6.85, they're both bigger than 3. I don't know what the other angles are. Suppose I could use a sine rule and find the other angle. Do something like that. Oh, here we go. That was a quick one. 4i. Oh, and I forgot my glasses. 4i's.